There are some equations that are actually almost impossible to solve using algebra, or at least they're very, very hard. In the next few videos, we're going to explore various ways in which such equations can be approximated. In this video, we're actually going to approximate the solutions by making consecutive guesses, where each guess will get us a little closer to the right answer. Today, we're going to take a look at an equation that is difficult to solve using algebra, and try to solve this equation using algebra. Then, we're going to try approximating the solution with successive approximations after we realize we can't really solve this with algebra. Lastly, we're going to work through a second example of solving an equation with successive approximations. By the end of this lesson, you'll be able to identify when an equation is going to be difficult or even impossible to solve algebraically, and you're also going to be able to approximate solutions to equations by making successive approximations. Let's jump right into it. So, we're given this equation and asked to solve for x. Pause the video and take a moment to see if you can solve this equation. So what you'll probably have realized is that we get stuck pretty quickly. The first thing we might do, so I'm going to go ahead and just rewrite this equation. So we have 2 to the x equals 30 over x minus 2. We might try to multiply both sides by x minus 2 to get the variables all on one side. So we have 2 to the x times x minus 2 is equal to 30, and maybe we multiply this out, so we're left with a 2 to the x times x minus 2 times 2 to the x is equal to 30, and we can simplify this a little bit further, so 2 to the x times x minus, and we can take this 2 here and actually add it to the exponent, because we're basically just multiplying by 2 one additional time. So it's the same thing, negative 2 times 2 to the x is the same thing as saying negative 2 to the x plus 1. So it's just one additional time that we're multiplying by 2, and that's equal to 30. So at this point, we're kind of stuck. So maybe we might try taking the log of both sides, but I don't think we're going to get anywhere anytime soon. So next, we're asked to approximate the solution to 2 to the x equals 30 over x minus 2. And we're going to round our answer to the nearest whole number. So this means we don't need to worry about plugging in any decimals. We're just going to be checking with successive guesses various whole numbers. And let's start with a very easy one. Let's start with 1. So if we plug in 1 for x, what we end up getting here is that we have 2 to the 1 is equal to 30 over 1 minus 2. And if we simplify this, we have 2 on this side is equal to 30 over negative 1, so that's just negative 30. We're pretty far off, so this is nowhere close to being equal. And what you might notice at this point is that x probably has to be, or actually definitely has to be, larger than 3, because this left-hand side up here is never going to be negative. And to make this right-hand side positive, x has to be 3 or larger. So let's just try plugging in 3. What we get when we plug in 3 is 2 raised to the third power is equal to 30 over 3 minus 2. And here, if we solve this out, we have an 8 on this side. We'll have 30 over 1, and so that's the 30. And so we're still pretty far off. And so let's just jump a little higher and go to 5. So we're going to plug in a 5 on both sides, and we get 2 raised to the fifth power is equal to 30 over 5. Let me do that in the right color. Is equal to 5 minus 2. And if we solve this out, we have that 32 is equal to 30 over 3. So that's actually just going to be 10. And here we notice we've overshot a little bit. So as you can see, as we go up with our value of x, this right side is growing very fast, and this the left side is growing very fast, and the right side is going down. So maybe let's try in between this, because here we saw we were still kind of far away, and with the 5 we overshot a little bit. So let's try to plug in 4 for x. So what we get when we do that is 2 raised to the 4 is equal to 30 over 4 minus 2. And solving this out, we have 16 on the left-hand side and 30 over 2 on the right-hand side. That's equal to 15. And this is pretty close. I mean, it's not equal yet, so this is roughly, approximately equal. In all these cases, I should say this is not equal. This is a little bit sloppy to write it this way, but we were just making guesses and seeing how close we got. And I'm pretty confident to say that 4 is the best whole number approximation that we're going to make here. So that is our answer to this problem, 4. In this next problem, we're asked to approximate the solution to 2 to the x equals 14 over x. And it's a very similar problem to the previous one, except this time we're asked to round our answer to the nearest tenth. And in this case, I would always recommend using a calculator. If we're asked to round to the nearest tenth, we're going to be plugging in some decimals, and solving this kind of equation when plugging in decimals is not very fun without a calculator. So the first thing I'm going to do here is actually kind of guess a few whole numbers that I can roughly estimate in my head to see roughly ballpark where we are and what kind of decimal solutions might make sense to plug in. Just so we don't start doing that blindly, because each guess with a decimal plugged into this equation is going to take a little while to check. So let's go ahead and plug in 2, because just eyeballing this, I can see that if I plug in 2, we're actually pretty close to the correct answer. We have 2 raised to the 2, that's 4, and on the other side 14 divided by 2, that's 7. That's not too bad. And I can check quickly by plugging in 3. By plugging in 3, I can quickly see whether or not the number will land in between 2 and 3. And by plugging in 3, we will see 2 raised to the 3 is equal to 8. And this side is, I'm just going to say, this is roughly equal to 5. It's a little smaller, but we can already see with that we're kind of going to be we're certainly going to be in between 2 and 3, because here this side was too small, and here this side was already too big. So as my first guess with a decimal, I'm just gonna go ahead and guess right in between 2 and 3, and I'll guess 2.5. And normally I would write 2.5 as 5 over 2, but because we're plugging this into a calculator, I don't mind writing this as 2.5 with a decimal. So that's 2 raised to the 2.5, and that's going to be equal to 14 over 2.5. Let me get the right color there. And quickly plugging this into the calculator, on the left-hand side, and so I've already done this ahead of time, but go ahead and pause the video and take the time to plug this in yourself if you would like to do that. So on the left-hand side, we're going to get something like 5.66. So that's, let me write that out here, 5.66. And on the right-hand side, we're going to get 5.6. So this is pretty darn close. I think we may have hit the nail on the head with this 2.5 guess. I'm going to leave it up to you to go ahead and check if one of the surrounding numbers, 2.6 or I guess really 2.4 would be the one we'd have to check, since this side is already a little bigger, and we know as we go up, this number just keeps getting bigger, this number just keeps getting smaller. So maybe 2.4 would be worth checking, and I'm going to go ahead and leave that up to you to check that. So we might ask ourselves the question, what types of equations are hard to solve algebraically? Let's start by looking at a few more examples. So here, yet again, we have, similar to the previous examples, we have x as an exponent itself, and we have x in another term. This is going to be very hard to combine, as we experienced earlier. Another example that's pretty difficult is when we have x inside of a square root and x raised to an exponent, like x squared on the other side, because after we multiply both sides or square both sides to get rid of this square root, we're going to have some pretty large degree terms. So we have x to the 4th, and it's generally going to be pretty tricky to solve this. Another problem that's not easy to solve is when we have x inside of a logarithm and inside of a term without a logarithm. This is going to be pretty hard to combine. So what have we learned in this video? In this video, we learned to identify when an equation is going to be difficult or impossible to solve algebraically, and we saw quite a few examples of equations like this. And we also learned how to approximate solutions to these equations by making successive approximations, basically by making better and better guesses and getting closer and closer to the answer until we have an answer that's rounded to whatever we're trying to round to, whether it's the nearest whole number or the nearest tenth. We could even take that further, but probably we don't want to be rounding to the nearest hundredths, because that's going to take a lot of guesses.